So why is the golden ratio considered to be the most irrational of all the irrational numbers? Well, it's rather simple. A simple continued fraction, that is. So recall that the simple continued fraction of a number looks like this. In fact, let's actually look at the simple continued fraction for pi first, so I can illustrate a point, which is this. Anytime the partial quotients, these numbers in front of the fractions, are comparatively large, that means the corresponding convergent by truncating at the previous partial quotient will be quite good. So a convergent is just a rational approximation to that irrational number. And by quite good, I mean that rational convergent will be rather close to the rational number in value. So you may have noticed that particularly large partial quotient of 292 there. So let's actually truncate at the previous partial quotient of 1. Computing that convergent, we would actually get 355 over 113, which, as you might know, is a rather famous rational approximation to pi. As you can see, it's rather close in value to the actual value of pi. Now, the reason why these particularly large partial quotients would give us such good rational approximations to our irrational number is because these large partial quotients would essentially reduce the size of the next fraction that will be added on in the continued fraction. I hope that makes sense. But this then means that if we wanted to create an infinite continued fraction that would be the most difficult for a rational convergence to approximate, then we should actually set all of the partial quotients to be as small as possible. So then that would mean the next fractions that would be added on in the continued fraction would be as large as possible. In fact, the smallest value for these partial quotients would be 1. So setting all of the partial quotients equal to 1, we get this infinite continued fraction, which is indeed the infinite continued fraction for the golden ratio, phi. So that's one way of understanding why we consider phi, the golden ratio, to be the most irrational of all irrational numbers, because these rational convergents would have the most difficult time approximating it, of getting close to its value. So essentially the difference between the value of the irrational number and the corresponding convergence will be maximized. The error will be maximized in a sense. Now, we can actually derive this infinite continued fraction for phi in a rather simple way. All we have to do is just observe that phi minus 1 is equal to 1 over phi, where phi, of course, is 1 plus rad 5 over 2. Now we just need to bring the 1 over, so phi is equal to 1 plus 1 over phi, and we just plug phi back into itself. And in doing so, we would create that infinite continued fraction we saw earlier. But in any case, that's again one way of understanding why phi is considered to be the most irrational of the irrationals. Now, of course, any video about phi, the golden ratio, would not be complete if I don't at least mention the term Fibonacci. And that's all I want to say on that, actually. In any case, I hope you're doing well. Make sure to hit that follow button for more math content. And as always, I'll catch you on the next one. Take care.